Hi, I'm Mike Tougeron. I'm a lead cloud engineer, also kind of the architect for some stuff at Adobe for our Kubernetes stack. With me, moving around, freaking me out, Carlos Santana. He's with AWS. He's a senior EKS solutions architect. So real quick here's some Adobe by the numbers. We run a very mixed environment, as you can see here. We got some Flatcar and Ubuntu. We got multiple cloud providers. We're across the world. We have 430 clusters and growing. Last time I gave this talk, I said we were close to 400, and that was in December, I want to say it was. We have over 240 Helm charts that could potentially be deployed to these clusters. So that's a combination of those. Not all of them, but some of them. And most importantly, as it's relevant to this talk, we have 90 people on the infrastructure engineering team of just developers in 7 countries around the world. So there's a lot of variety in all of these numbers and all of these variations that affect the way in which we deploy our applications to these clusters using Argo CD. So what's really our problem? Our problem is, how do we keep the lights on? So in February of this year alone, we had 554 deployments of our cluster add-ons to our fleet. So think about that number for a minute. 554. That's like 20 deployments a day across this fleet. So with Argo CD, I assume you all are familiar with it in there, have looked at the metrics. What kind of metrics you get out of the box for that kind of variation? Think about it, 554 times 200 and something. We have 50,000 applications that are deployed out to our fleet. How do you look at that? So the gaps from Argo CD metrics aren't out there. So we have to fill it in with Prometheus metrics, Argo CD notifications, but the volume of change and the matrix of possibilities of application versions with the attributes of those fleet creates a visibility problem for us. So we kind of show this little, chart here on the side that's just with some fictitious data, but it starts to represent the complexity of this problem. Different cluster versions, different applications, different versions of each of those, and we have to bring it all together in a way to show this in a nice, easily visible manner. So Carlos here is going to talk a little bit about how some of this comes together.
Yeah. So what we see here are using groups. So in Adobe, they have this approach of giving clusters an attribute. This could be labels and annotations when you create a cluster secret in Argo CD. And what this provides you is ability to group clusters based on maintenance. So in case of Adobe, they use a single application set per add-on, and then that application set will be in charge of deploying that specific add-on from their 240 add-ons, possible Helm charts that they have, to the individual clusters. So the idea is to have that single application set. Doesn't matter which Argo CD instance, because in Adobe they have multiple Argo CD instances, each one handling around 2,500 Argo CD apps, and we're just talking about add-ons. So it's a way that they can do promotions based on application set grouping. So in this case, we'll be looking into how to do the groupings of, for example, production. So production is an environment that they have these add-ons on different clusters are in production, but you have to have a second layer of grouping. In AWS, in EKS clusters, we call them cluster sets. In Adobe, they call them maintenance group, but you can generally say it's a group within the production fleet that you want to upgrade an add-on or patch an add-on, and then go to the next group. And that group could have the same number of clusters, or they can have more clusters in it. As a best practice, you want to have more clusters because you don't want to take a linear approach of rolling out an add-on. You want to have an accelerated way of, as you promote the add-ons, you feel more confidence for the next set of grouping to be bigger, so that way you can promote your clusters around different regions, or depending on how you do the grouping. So the idea you can see here in the screen is I have 2 groups. Group A for production has 2 clusters. Group B for production has Group B. Group B has 4 clusters. So how this looks like in an application set. So what you see here, and you're not going to get away without seeing more YAML today, this is an application set section. It's not the whole application set because then people cannot see it. But the idea is to have a flat cluster generators, or you can use the merge generator to have a merge cluster generators. And the first one will be your default version of the add-on, and then you use selectors based on those attributes. So the cluster is dictating which add-on and which version it will get. So for example, at the top you have the CR or dev, they're getting the 117. The next one is staging, and staging has two groups, group A and group B. So they have different versions. And then the next set is production, where in Adobe, this is a Adobe showing how they do things, they have Canary. So that maybe have one cluster, and the next group is group A that has, for example, I was talking before, 2 clusters, and then 3 clusters, but it could have n number of clusters. The idea is that you want to minimize the blast radius when you do it in an environment. The other thing is that in Adobe, they use a lot of automation and CLI tooling to be able to upgrade these add-ons at any time. Like Mike said, they do 554 add-on patch updates, and they do it with pull requests. And they use Prow as a way of managing those pull requests and start merging them as they do the testing. They want to move to use progressive sync as progressive sync gets more stable. Right now it's in alpha. There's a few features missing, like handling sync waves is one of them that they will need to have in there. But the idea is to have application set be the one that controls all those add-ons everywhere. Mike?
So as things get deployed out, you kind of have to expect the unexpected, but some of these things that you see on here are expected. You know, when you start the sync, something can go wrong. You know, you're missing your get access, so your sync is going to fail. Or you have a deny sync window for some reason on the application or on the cluster. All right, fine. Well, you get to your dry run. Well, perhaps a CRD isn't on the cluster yet because, well, things are eventually consistent. You're trying to deploy a Prometheus rule. Prometheus operator hasn't been deployed yet. You get to admission controller problems. Okay, you have a OPA gatekeeper preventing things, or we have precincts that do checks if there's some sort of outage on the cluster or there's some sort of customer incident on the cluster. We can prevent syncs from happening so that as the SRE team, operation teams, or application teams are troubleshooting these major incidents, changes don't happen on the cluster while they're trying to troubleshoot what's happening. You know, nothing worse than having change something you're trying to fix at the same time. Then you get into the whole sync issues where things are actively syncing. Well, maybe you pushed a bad image tag. Well, that's a horrible sort of thing. Or you have an application that's failing to start because you have, you know, a config map that hasn't been created yet. And then you get into just a whole bunch of other possibilities that are out there of just what's not working with your deployment. I'm sure you've run into a lot of others than what I've listed here. You know, one of my favorite is, you know, testing. That just doesn't always work. So our solution to this is to create some new metrics. So you may not be aware of this, but KubeState Metrics has this really cool feature where you can capture fields from the CRs that were created from CRDs and emit that as metrics. So what that means is your Argo CD application CR, you can grab something from there, such as the operation state started at time and finished at time, or any other of those attributes that are on there, such as your source revision, so you know what version is deployed, or any number of other things. We also pull things from the app project so that we can find out the sync window information for an application or for a cluster and things like that. And then we jump into Prometheus rewrite rules. This is where it gets kind of complicated. We have a repo that we'll talk about in a few minutes, but when you look at that, we're looking at 350 lines of YAML here that do all of this configuration. So it's not a quick, simple thing, but it's actually quite simple once it's running. We process all of this data, combine it together with the Argo CD app info metric that's already emitted, and we create this detailed metric. We pull it together with these other metrics that we've created from KubeState Metrics, And we're able to create these ones, a sync window metric to know which applications or clusters have deny or allow sync windows. We know which applications are long running for their syncs, and we know which applications are out of sync for some reason. And what's really cool is we can combine those metrics with the sync window ones. So if something's out of sync and has a deny window, or vice versa. And I don't know what's especially important with the long-running sync. I don't know if any of you have run into those never-ending sync with a deployment. We run into those quite often because of our scale. This helps us identify those. So this leads us into the don't distract me problem. Argo CD has some great ways of doing notifications. It has that notification plugin. When something is out of sync, not healthy, degraded, progressing, and so on, you can send out those notifications. Well, when something's out of sync but has a deny sync window, as a developer, do you actually care? Probably not, because you have a deny window on there for a reason. If you have an allow window and the application is progressing, do you want to be notified of that? Probably not, because you may have just done a deployment. But if that progressing has been going on for 2 hours, you probably want to know about it, because most Kubernetes deployments don't take 2 hours to happen. But you do want things to alert if they're in a degraded state or if they're not healthy or out of sync or things like that. And so the built-in Argo CD one, as you can kind of see here in this slide, there's a lot of ways to get false positives. And what these metrics do is they help us filter things down to only get the failing deployments. So what I mean by that is we start by gathering those unhealthy applications. Those are fairly easy, right? It's the ones that are not healthy, those that are degraded, those are out of sync, and so on. But then we get those that are started at 90 minutes ago and don't have a finish at time. So those are still running for some reason. Maybe they're stuck in a pre-sync or post-sync hook. Maybe for whatever reason, they just haven't come up with the deployment. Maybe they're in a retry loop because you have things going on with that. Who knows? There's lots of reasons, as we showed in the previous slide, that can happen. Then we have the sync windows. Well, like I said, you don't want to have the deny sync windows alerting, because you don't, it may not actually matter. So you start filtering all of these things out, and finally you have your out of sync applications, and you can put it together in a nice dashboard and send alerts based upon that. And that way there, when the alert hits the developer that made the change, or hits the operations team, whoever's responsible for the deployment of this application, they get something that's actionable and relevant, and so they can take the action that needs to be taken to make sure that the application is healthy. So with that, Carlos is going to show us something really cool.
Okay. So what we're going to show here is a demo that is composed of a few things here. As you can see in the screen, at the bottom we have a utility called the IDP Builder CLI. It's a binary CLI that you run in your terminal from the Canoe project. It's a project that I work for on building internal developer platforms. And actually it's a tool that I told Mike, let's build a demo using this tool, because we can go back and forth. And we actually collaborated on this, was able to delete the environment and run one command and get it up and running. And we changed things and we modified things, and then Mike deleted it and created it again, right? So we were able to have one command to just bootstrap everything. So this CLI will give you a kind cluster. It will give you Argo CD, Nginx, and Git, which is a Git server in your laptop. That way, it would take all the YAML files and create repos. If you modify the YAML files, you can have a watch mode, and it would automatically copy the files, like basically do a git add, git commit, git push, automatically for you. And then from that point on, it's Argo CD 101. So in this case, we're using vCluster to simulate a large amount of clusters with the attributes that we want to deploy. And we deploy a couple of fake apps that have some problems that we described, like the long-running one, the out-of-sync, the degraded. And then the vClusters are registered using external secrets, and then we use the Kube Prometheus stack Helm chart that will give us Prometheus Grafana, and then Kube State Metric, which is the one that we're going to collect information from apps and projects. So to show that, let's exit here and move on to the demo. So in the demo, what we have here is the one-liner command that you run. You git clone this repo, you run this one command, and the only thing that you have to have in your computer is Docker, for example. After that, as you can see here in the first one, you will see one of those examples of setting the merge generator for the add-ons. In this case, we have Cert Manager and the fake ones. We have in here a portion of the cube state metric configuration, which will grab the information from the Argo apps for the sync time start, sync time end, and create that custom metric. Then we take information from the app projects to have the sync windows extracted, and then do a join using Prometheus rules, which we have here. And then we have Prometheus here doing the rules to create the new metrics that I care about, and taking into account the sync windows on the projects and the start and the end time. So with that, let's move on to Argo CD. So in Argo CD, we have here a bunch of apps, basically. The ones that are easy to identify are the ones that are degraded. So in this case, you may get alerts that there's something wrong with Argo CD, but in our case, like Mike described, I don't want to be distracted because there might be a sync window, a deny sync window saying no syncs should be happening on these apps, and I should not get an alert. Another one that is easy to identify with is out of sync, right? But I don't want to get notified if there's a window applied to it. And the way that Adobe does it is they use it as a gate. So if somebody gets paged and is working on a problem, they basically put a sync window on that app to say, stop from alerting me because I'm working on it. And then once the sync window is removed, then it's normal operation. So if there's the metric will show up, then alert me. And the last one is, who in here, and the healthy ones, is there's one app in here that is long running, one of those apps that is healthy, but it's like you're asking yourself, is it running or is it stuck? So it's like taking 30 minutes, 40 minutes. So in the example that you saw about Prometheus rule, Mike wrote a rule saying make a metric, a custom metric show up if the app is taking longer than, in Adobe they use 1 hour. In the demo, we just put 30 minutes in there. So, but it's very difficult to detect that there's a problem, that there's an Argo CD app being stuck. So if we go to Grafana, and this is, again, out of the box, it will come up with a dashboard. And then you will use your typical Argo CD Grafana dashboard for utilization, like CPU metrics, operation, those type of things. But then you want to create your own Grafana dashboard or whatever observability that you have to create your custom metrics. So as you can see here, there's a couple of clusters and applications that have the sync window. So this is simulating that the team is working on those problematic applications. So if we go back to done working with those apps, I can go into the sync window and detect and delete the ones that have the problem. So for example, in here, I can detect, let me see, I click the wrong one, this one. Let me remove the window for...
Adjust your size. I think it got screwed up.
Where are my things?
Louis not showing it for some reason.
It's not showing up for some reason.
You can just delete the whole window.
Delete the whole window?
Yeah, that'll do it.
And then the idea is that
You gotta speak up.
when the sync windows are gone, the applications will show up at the bottom. So as you can see here, there's a couple of sync windows that are always apply, and there's sync windows that are scheduled. So as you can see, I removed the problematic apps, and they show at the bottom. So at the bottom, you can see that there's apps that are degraded, apps that are out of sync, and then in this left side, right side, your left side, you can see the long-running ones. So this is at the time that I want to get alerted. For example, alerted through Slack or your chat application, and Mike will show how they're doing it in Adobe on how to show those problematic things. So this is the idea of a quick demo that you can use to start like emulating a multi-cluster setup in your laptop and start like creating those metrics. One thing that we forgot to mention is this work of example of Q-state metrics, Prometheus rules. We're planning to put them in upstream in Argo CD to have these type of resources available for folks to create their custom metrics, and as a community have more operational assets available in Argo CD. Let's go back to the slides.
Thanks, Carlos. Yeah, so that's great. So we got a lot of stuff. We filtered it down. We know what we're looking at. But sometimes that's not great. Who are you going to tell this problem to? So with that information, you could send it to a generic Slack channel. But what if that person, as I said, is not awake anymore? We're in 7 countries around the world, 90 different people. So sometimes you need to enrich that with additional information. So in our case, we have an agent that runs that then looks up the Argo CD resource, looks up the commit information, goes back to Git, looks at the commit history, finds out who made the change, either to the app set, to the Helm chart, to the values repo, to wherever it came from, enriches the alert with that information, then sends the Slack message not just to a general channel so that everybody knows that there's a problem, but also directly to that person saying, hey, look, you got a problem with your deployment, you need to do something about it. And the great thing with this is for those long-running ones, they don't have to remember to come back in an hour and check that it worked or check that it didn't work. It's an active system and you know what's going on. You can kind of see a screenshot of what it looks like. It gives that additional information beyond what's available. This is another thing right now. It's something I was playing around with 2 weeks ago. We released it last week internally. Someday I would like to clean this up so it's not Adobe specific and the general community can use this as well. Like Carlos mentioned, all those Prometheus rules, cube state metrics are in a repo. Here's the QR code to it. We do want to get this into the Argo Labs or Argo CD repo itself, but we're still working out as to which one of those two it belongs in. Please rate our survey, or take the survey, rate our talk, not rate the survey. We do want your feedback. Here's how you can get a hold of us. I am on CNCF Slack and Kubernetes Slack. I believe you're the same. Thank you very much. And if you have any questions, we do have a minute or two. If not, we'll be outside. Yep. Carlos?
Yep. Thank you so much.